people taking the state test can get access to what they need to put on the Nearpod. Okay, so, and again, anything that's in the chat actually doesn't get recorded, and then your pictures don't get recorded unless I make you a presenter. So I am going to switch over to share what is on the doc-cam. You guys should all be in the Nearpod on slide number 11. Yeah, slide 11. And we're going to be subtracting negative rational numbers today. So last class period, we were subtracting positive rational numbers. And when we subtracted positive rational numbers, we needed to move in the opposite direction of what we did before, right? It seemed kind of weird, but because we were moving to the left when we subtracted positive numbers, it was kind of like when we added positive numbers, we knew that we need to move to the right. If we looked at our rule number 4 or section 4 of our Nearpod, but we were doing the opposite, right? The opposite order of operations. So it gave us kind of like kind of the indication that we need to do the opposite of what we were supposed to do for that order of operations, right? That's why we didn't necessarily have a new rule when we talked about subtracting positive rational numbers, right? We just followed the steps from step 1 where we started at the first number in our equation on the number line, and then we moved to the left because we were subtracting a positive number. When we add a positive number on the number line, we move to the right. We're doing the opposite, right? We were subtracting. So today we're going to talk about subtracting negative rational numbers. We're doing the opposite of what we were doing with our order of operations when it came to adding. So again, we're going to be working with rational numbers. Our rational numbers, oh my gosh, a bunch of kids just came out. I told you, I think it was lunchtime. So we'll see if this works out. If not, I'll just go back in the classroom because I think that they're going to be quiet now in the classroom. But our rational numbers, that encompasses our whole numbers, right? And our integers. Integers mean that we have whole numbers, but we also have the negative versions of our whole numbers. And then rational numbers are any number that can be expressed as a ratio of 2 integers. And that sounds kind of weird, right? The ratio, but like we see a ratio every day when we're on the road, right? Because when we see a speed limit, it gives us how many miles per 1 hour we can go. And we don't see it written this way, right? Though we see it written like 60 mph, because as a whole number, we have a whole number over 1, right? And that still equals just this whole number, but we usually see it just written like that. Okay, so that's why rational numbers encompass decimal points and fractions, as well as the negative versions of the decimal points and the fractions. Kind of feel like I want to show you guys all the kids walking by right now, but we'll keep going. So for section 3, we were added rational numbers with the same sign, meaning if we added positive numbers, we had 2 positive numbers, right? Or we added 2 negative numbers. When we added numbers together with the same sign, they increased in value. Remember, we have sum, meaning the total amount of the numbers that we have added together are added values. So if we had 2 negative numbers, like if I had -5 and -4, I added them together, right? I added 5 and 4 to give me -9. Okay? Right, so, and we learned there that when we move on the number line, if it's positive, we're going to increase in value to the right. If it's negative, we will increase in value to the left. Right? And then we talked about adding rational numbers with different signs. So when we added numbers together with different signs, meaning we had one positive and one negative, we had to do something different, right? Because we didn't have two positive numbers. Can you guys not see? 12:35, 3 minutes ago. Can you guys see now? My screen right here. Kevin, can you see? And can you guys hear? Yeah? Okay. So when I'm adding rational numbers with different signs, I had to do a kind of a different process, right? We were no longer just adding. Our rule told us for adding rational numbers with different signs, we needed to find the difference of the absolute values of our numbers, right? Meaning if we had -3, we used just the number 3. And then we used those values to subtract the smaller number from the larger number, and then we used the sign from the greater number, right? So if I had -5 plus 3, I took just the absolute value. Absolute value of -5 is just 5. Absolute value of 3 is 3. And then I had to find the difference, meaning I needed to subtract. So I had 5 minus 3. That is equal to 2. And then I needed to take the sign from the larger or the greater value. My 5 is larger than 3, so that made my 2 negative. So -5 plus 3 gives me -2, right? Another really important thing that we learned from this page is the number line rule. I mean, this is always true. When we move to the right, we are becoming more positive. Or if we look at 0, and as we move to the right of 0, the numbers are positive, right? Always going to be positive. For the negative numbers, as I move to the left, I become more negative, right? Or I start to become negative if I'm starting over on the positive side. Or if I'm thinking like starting from 0, my numbers increase in value to the left on the negative side. So my negative absolute values will increase as I move more to the left. And this is super important as we move forward with working with numbers with different signs, okay? And this is going to hold true and importance as we move into multiplication and division of positive and negative numbers, okay? With the additive inverse, remember that was really easy. We talked about how it's important now to think of numbers as a distance. The value of a number being a distance from 0. And this is so important because when you get into 8th grade, you're going to learn about Pythagorean's theorem. And these numbers from 0 are no longer going to be its value as in like, oh, I have 10 candy bars and I ate 4 of them, so now I only have 6. But the distance from 0 is going to be a measurement, right? We're going to take something and our 0 is going to kind of become like our point, our plot point, our starting point. And if I go a distance of 2 over here, I have a value of 2, and then I go 2 over here, that means my absolute value, right, is still 2, even though I'm on the negative side, because I'm taking the opposite of these two numbers. If I'm additive inverse, that means I have positive 2 over here, -2 for my additive inverse. My distance, meaning my value, stayed the same. The only thing that changed was my sign, right? I went from +2 to -2 for my additive inverse. So the only thing that is changing is my sign, because the distance or value is going to remain, okay? So we are now getting to what we talked about on last week, our last class period together. We used a number line to subtract positive rational numbers. So we saw that if we are subtracting, right, a positive number, meaning it's going to either be positive or negative for the first part of my expression, right, or equation, it could be positive or negative. But the important part is that what I'm subtracting is a positive value, right? So right here I have positive 6.5, I am subtracting positive 7.25. And because I'm subtracting a positive number, that doesn't mean that I'm going to move to the right, because my second number is positive. I'm going to be moving to the left because I'm getting rid of that value, meaning like I have 6.5 and I am subtracting in value, or moving towards the negative direction, 7.25, right? And that's why I said when we have 6.5 minus 7.25, it's kind of weird how we look at that math now and we go past 0 and have a negative value, which is not something we're kind of used to, right? But we are increasing in value on the negative side. So when we subtract, we are moving to the left to increase our value on the negative side, or toward the negative side. Okay, and on rule 6, we didn't really have a new rule, right? We didn't write anything new, we just saw the steps, the process along the way. And now for 7, we will have a new rule, okay? So let's start here. We're going to talk about our new rule that we have for 7, because we are going to be subtracting negative rational numbers today. Who's this? The kids that keep yelling. I'm at Washawn Elementary, so our campus is at an elementary school, and it is lunchtime here, so it's just the kids that go to school here at Washawn Elementary. So sometimes when we're outside, we can hear the high schoolers, because the kindergarten classroom, the room that I'm actually in every day, is right next door to a kindergarten room with a bunch of kindergarten kids. So if you ever hear yelling, that doesn't sound like the teacher's yelling, but little kids, those are kindergartners. And then sometimes we hear the high schoolers, not very rarely, but if they're playing baseball. We're kind of close to the baseball field. All right, so today we are going to be subtracting negative rational numbers. Right, so we're going to be subtracting negative rational numbers. We can let that rational number be represented by y. Okay. Here is my negative number. What I want you guys to really pay attention to is, if I am subtracting a negative rational number, that means my first rational number, let's see, it's x. We don't know what it is. It could be negative or positive. It doesn't have to be one or the other. The rule will remain the same whether we start on the negative side of the number line or the positive. The important part is that I know that what I'm talking about or learning about today is I am subtracting. That's my order of operations. I'm not adding, I'm subtracting a negative number, not a positive. This cannot be positive. It has to be two negative signs next to each other. Okay? So, to subtract, right? To subtract, according to this rule, to subtract negative, right? Negative rational numbers. Right?
Sorry, I was on a call. My bad.
Right here, right? To subtract negative rational numbers, move in the opposite direction on the number line, and by opposite we are going to move to the right. So we are not going to be moving in the left direction, right? Because usually when we subtract, we think we are going to move to the left because we're taking stuff away, right? But I want you guys to kind of think of this in a different way. So we saw that when we add negative numbers, right? When we add negative numbers, let me go back to that. When we add numbers, if I'm adding on the negative side, right, it usually means I'm going to move to the left. But that's when I add. And right now I'm subtracting. So if I'm subtracting, I'm going to want to do the opposite. That's why it says I'm moving to the right, because I'm doing the opposite of adding, I'm subtracting. And I want you guys to kind of think of this theory in a way, or think of this example. Say I have 4 negative pins, right? This is a -1 pin, -2 pins, -3 pins, -4 pins. I am going to subtract 2 negative pins, right? So I have my -4 pins right here. I'm going to come in, I'm going to buy 2 of those negative pins, right? So let me just take these 2 negative pins away. I am left with 2 negative pins, right? So if I look at this, I think, I have -4 and I minus -2. I have 2 left, right? If I look at this from a number line kind of point of view, -3, -4, -2, -1, 0. So I'm starting here. I have 1, 2, 3, 4 pins, right? I just keep them here on my negative side. I'm going to take 2 of them away, right? -4, so here's 1, here's 2. I took 2 of them away. So that means I am left with only 2 pins left, right? I have 2 negative pins left. So my value is now -2, because that's what's left. So I moved over 1, 2 to get there, right? And I moved to the left. And I move to the left when I add, right? I move in the left direction when I add negative numbers, or when I'm adding just in general, right? So what I can do to make this math problem easier is I should say I have -4. Remember, I told you guys in math it is the only time when you have 2 negatives and it makes a positive. So I have my minus negative right here. I'm going to turn that into a plus sign. So now I have -4 plus 2, right? If I have -4 plus 2, that is going to give me -2. Right? That makes sense? So I need to know, I need to be able to conceptualize that if I have -4 minus -2, I can't make that increase in value because I am taking away from my -2 value, right? So I need to move towards that 0. All right, let's go back. I'm gonna go back to here. I'll show you guys again on the number line, because the only way to really make this make sense is with practice, honestly, because it just kind of seems like it's an unreal concept that we go from subtracting a negative number and our value gets smaller, right? And it goes towards the positive side when we're subtracting. But that is how it works, okay? So I have -1/2. So I'm going to start here at my -1/2, right? It's my step 1. Let's see, for my number line, I need to make sure that I can read the number line properly. I need to make sure I know how to, what each little line is worth, what its value is. So from 0 to 1 is divided into, let's see, 1, 2, 3, 4, 5, 6 sections, right? So that means each of my little lines can be worth 1/6. And if you guys notice, when I counted towards the half, I had 1, 2, 3. So that means that my 1/2 is valued at 3/6, right? And we know that 3/6 is an equivalent fraction to 1/2. It's just simplified, right? Because I can make this 3/6 smaller by dividing the top by 3, dividing 6 by 3, and that gives me 1/2, right? So these are equivalent fractions. They're equal in value. So I'm going to start at my -1/2, which is right here. And then I am minusing -4/6. So if I am subtracting a negative number, I need to move in the opposite direction, or that means towards the right. So I need to move to the right 4/6, right? And I don't need to think about it as like minusing or going this direction, because if I am subtracting a negative, rational number, I move to the right. So I just need to move to the right for 6. I move that absolute value for 6 to the right because we are subtracting a negative number. And we just follow that rule. Just like in science, we follow that rule. We know it to always be true. Okay, so I need to go for 6. So each little line is worth 1 6. So here's 1 6. Here's 2 6. 3 6. And 4 6. That's me minusing 1, 2, 3, 4, the negative, right? And now I need to read, here's my step 2, I need to read my number line, which it's now in between 0 and 1, so I know that it's not greater than 1, so I won't have a whole number here. I'm here 1 over, so one little line over from 0, so it's just here 1 6, and it's positive 1 6. And again, if you guys look, I moved to the right and moved to the left. So if I was to look at this, and I know that I moved to the left, and like I said, if I have 2 negatives, I can make that a positive, right? Let me show you one more time. So I have negative 1/2, which I showed you guys is also equal to negative 3 6, right? Because it's 1, 2, 3 lines over, making that equal to 3 6. So let's see, I have negative 3 6. Then I know for my order of operations, I'm going to be subtracting negative 4 over 6. Let's pretend like we didn't use the number line here. I don't have one, but I know my rule. I need to move in the opposite direction. So I'm going to listen to Miss Gabriel, what she said, what she taught me in 7th grade math is if I have 2 negatives, that makes a plus sign, right? That makes a positive. 2 negatives in math makes a positive. My denominators are the same, so I leave those alone right now. Negative 3 plus 4 will give me a positive 1, right? That equals positive 1. So I'm looking at it from a number line sense. If I go over negative 3, if I go over 1, 2, 3, 4, I have negative 3, negative 2, negative 1, 0, positive 1, right? In case I still need to use a number line of sorts. I have positive 1. My denominator stays the same, so I have 1 6. Does that make sense? So when I use my number line, I use my rule that I had for subtracting negative rational numbers from the number line. Right? I move in the opposite direction. That still proves true when I had to do the math, and I just worked out the math problem, right? I got a positive 1 6. Sure, Isaiah, you can go and restart your computer. I have this recording, so let me know if you need it, if you missed too much and you need need me to send you the recording. All right. Does that make sense to everyone? I know it does seem like a kind of like a weird concept in itself, but if we think about doing the opposite of what we do when we add, this makes a lot of sense, right? Because the order of operations in itself, adding and subtracting are the opposites. So when we need to find the answer, we have to do the opposite steps, right? Because instead of adding, right, instead of adding value, we're taking it away. So that means we need to move the opposite direction that we would move on the number line, right? So let's kind of put it like in words or in another rule to an extent. If I am moving, right, here's the direction that we're moving on a number line. If I am moving in the negative direction, right, if I move to the left on a number line, I am moving to the left because I am adding a negative number. Adding a negative number. I'm adding value to the negative side, right? So I need to move to the left. The value is being added. Hi. to the negative side. So let's see. So now I'm going to move. Let's see, like if I'm doing the opposite, right? If I'm going to move to the left, right? If I'm going to move to the positive side, I can correlate this to our number line rule that we wrote down and discussed on section 4, rule 4, however you want to label these. Our number line rule is that positive numbers move to the right and negative numbers move to the left, right? But our rule applied to math theory, we move to the right on a number line to subtract a negative number. So in order to subtract a negative number, we need to move to the right. So when we added a negative number, we moved to the left. All right, and here's a little bit of practice. Okay, we're going to go back to practicing adding a positive number. It's kind of like what we learned last time. So if I have negative 8, right, and I am subtracting a positive 2.5, right, because there's the negative sign in front of it. That means I'm not going to follow this rule here. Right? I'm not going to go the opposite direction because I am subtracting a positive rational number. So I'll be using the steps that I used in for rule 6, right? So I'm going to move to the left because I am subtracting a positive number. So when I do that, I'm going to be starting here at negative 8, right? Because this is to start at your first number in your expression. Actually, this is an equation. There's an equal sign. So I'm going to start here at negative 8. If I look at my number line, I know that each number is divided into 1, 2 sections, right? So my denominator is going to be 2. So each little line is worth 1/2. 1/2. So I have negative 8. I'm subtracting 2.5, so I need to move to the left. That's what our rule told us. If we are subtracting a positive number, we move to the left, right? It actually says adding a negative number, but we are subtracting a positive number. So I'm going to go 1 over, right, 1, 2. It's for a whole 1, so minus 1, minus 2, and then I need to go over another half, so minus 2.5. So now I need to read my number line, right? Step 3, read my number line. It's in between negative 10 and negative 11, so it's greater than negative 10, so my whole number would be negative 10. And then I'm here in the middle, which is worth a half. Hi guys. Sure, I will give you a high five. So no problem. A half is worth 0.5, right? 1 divided by 2 equals 0.5. Right? And they're all saying I'm on a call. Okay, so a half is equal to 0.5. So I have negative 10.5. Because I added a positive number. Meaning my negative value increased because I was adding to its value, right? It became more negative. Does that make sense to everybody? At least a little bit? All right, so what I'm going to do is I am going to give you guys 4 minutes for the guided practice. Now this one is a little bit difficult. Make sure that you understand what the question is asking you. So use the number line to find the difference between these two numbers. We learned about today subtracting negative rational numbers. We practice subtracting positive numbers. So make sure that as you read the question, you're understanding if it's asking you to subtract a positive or a negative number. And then also in the last part of the question, what it's asking. Is it asking for the overall change? Is it asking you to find the difference? Or how far below sea level are you? Make sure you understand what that means as it pertains to the question, okay? So I'm going to start that timer. I'll give you guys 4 minutes to complete the guided practice. In 4 minutes, what I'll do is I'll check your guys' answers. Of course, you get credit for participating and for trying. And then I will look to see how many we get correct, and if we get them all correct, we don't really have to go over it. We probably will, just because I want to make sure that you guys do fully understand it, and in all my other classes, nobody got every single one correct, so I don't want to put us in a position where we're, we don't understand. But I will do that, and then if you do get them all correct, I'll give you guys a bonus point. So let me put that timer on. Let me find it. I found one today that didn't have annoying music or like an annoying fire alarm at the end. Alright, so I'm going to share timer so you guys can see it. Okay, that 0 is actually kind of creepy sounding, huh? All right, so let's see. Let me go back into this. Let me start sharing my screen so that way you guys can. Let me look through, see what you guys got. All right, so Jacob, I got yours submitted. Aisha. Those. Computer user in progress. Make sure that you do submit it before we go too far forward. Actually, submit it just before the end of class, because I will go over it. I know we only have 10 minutes, but I do want to go over the process with you, because I have quite a few students that just didn't submit it. You guys are writing on it. I can see that, but that tells me that maybe you guys aren't fully understanding, and that's okay. Oh, thank you, Kevin, for letting me know. I do appreciate that you guys do something confusing, because then it lets me know that I need to explain it a little bit more. All right, so right here I have the number line. Let me share on my dot cam. Again, contents for my camera, and I'm just going to go until 120 using my dot cam. So if you guys can bear with me, and then make sure that you put your answers in. I'm pretty sure this will take until the very end of class. All right, so just like on all of our other number line rules, it says to start out at the first number of the expression, right? So this is our indicator of where to start, kind of like our origin. So I have a negative 1 3/4. Right, I'm going to look here at my number line. I see that I have little lines. I want to make sure I know what those mean. So my whole number here is split into 1, 2, 3, 4 sections. So that means the denominator is 4. Each little line is worth 1/4. All right, so if I look here, I am subtracting, right? Subtracting 2.5. This is a positive 2.5, right? Because I don't have anything here indicating that it's negative, so I am subtracting a positive number. And then I do have on here on my second number, my positive number, I have a mixed number, and the fraction itself is not in quarters, it's in halves, right? So I need to get my 1/2 equivalent to something with 4 as my numerator. So if I have 1/2, I need my bottom numbers, right, my denominators to be equal to each other. So if I look at 2 and 4, I know that I have 1 on top, so I can't divide 4 by 2, but I can multiply 2 by 2 to equal 4. So if I multiply this by 2 to get 4, I need to multiply my numerator by 2 to make this equivalent, right? Because I have to do the same thing that I do the bottom to the top. So 1 times 2 equals 2. So 2/4, right, or 2/4 is equal to 1/2, right? They're equivalent ratios. So I'm going to add 2 and 2/4. That's just going to make it easier for me as I move across my number line. Okay, so if I start at negative 1 3/4, right? This means this whole number is negative. I don't move 3/4 in the positive direction, because then that would give me less than 1. So negative 1, and then I need to move over 3/4, so that's going to be 3 little lines. Okay, so my starting point is here, I need to start here at negative 1, and then move over 3 little lines, 1, 2, 3. This is going to be my starting point, negative 1 3/4. Now I'm subtracting a positive number, so I need to move to the left, right? And I know that because of my rule on number 6. When I am subtracting a positive number, I move to the left, right? So if I move to the left 2 and 2/4, I'm going to go over 1, 2, 3, 4, right? That's minus 1. So it's in 4 sections. 1, 2, 3, 4. This is going to be minus 2. And I need to go 2/4, right? 2 little lines more. 1, 2. So it's minus 2 and 2/4. And now I need to read the number line here. So I am in between -4 and -5. I have more than -4 but less than -5. So I know my whole number value so far is going to be -4. Right? And my number line, I am one little line over from -4, so I need to add on that quarter. So my answer for number 1 on the number line, when I subtract my positive number, I have -4 and 1/4. Okay? Remember, when I see the word difference, I know that means I'm going to be subtracting. So I am subtracting my positive number, -1 3/4, minus 2 1/2. That gives me -4 and 1/4. All right. So question number, I'm going to jump to question number 3. Number 2 is good too, but I know that we won't have time to finish number 2 and number 3, but I feel like number 3 is easier to explain why we are adding in value when we are subtracting negative numbers, okay? So Jackson and his father went scuba diving, right? And when you go scuba diving, that means you go underneath the water, right? So here's sea level, here's the ocean, right? So Jackson and his father went scuba diving. At their first location, Jackson and his father were 8 feet below sea level, right? I am below sea level. That means I am -8, right? I went down 8 feet, right? -8 feet, right? All right, so my next part of that question, they moved to a different location. That was 9, right? 9 more feet below sea level. So I'm going to add in value to 9. So I have 9 more feet. Apparently I look really weird sitting out here. I've had a lot of people stop me, ask who I'm talking to. I have 9 more feet, right? I increase my downness by 9 feet, right? So here's my second location right here. Location number 2. This was location number 1. Right? So they moved to a different location, 9 more feet below sea level than the first location. So how far below sea level? How far below sea level are they scuba diving at the second location? So at my second location right here, how far below sea level am I? All right, so mathematically, this equation would be written out as -8, right? Because I'm below sea level. And then I'm going to go 9 more feet down, right? So I could add, right, -9. Right? If I add -9, I would still, we could look at it be written as -8 minus +9, right? Because I went 9 more feet. That's going to give me the same answer, right? Because I need to add these two values, these absolute values together. If I have 8 feet down, I went 9 more. 8 plus 9 is going to be 17 feet, right? 17 feet. Or if I have -8 plus -9 or -8 minus 9, that's going to give me -17. -17. So remember, if I have two negative numbers and I'm adding them together, their value increases to the left, so that means I'm going to take these and add the values themselves. 8 plus 9 equals 17, but I'm going to keep my sign negative. Or negative 8 minus 9. If I move on the number line over 9, right, I'm going to go 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, negative 17, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces over, right? So just subtract that 9 here at negative 17. So the question says, how far below sea level are they scuba diving at the second location? This part below already tells me that I'm in the negative area. So I'm going to be below sea level 17 feet. So my answer is going to look positive, right? Because it's written here. It's verbally written. The meaning below sea level tells me that it's going to be a negative number. I'm below sea level and I'm below 17 feet. Okay? And it's 1:20, so I'll let you guys go. If you guys have any questions, I'll stay here after and answer them. But for today, that we are done with the guided practice, make sure you hit submit so your work doesn't get erased. Make sure you check your grade because it should be up to date within your pods in there. Okay. And so we have right here our answers to 1 and 2. Try to do 2 on your own. This one is a little bit confusing. If you look, the question says that we have in December, it was 1 1/3 feet below normal. And the snowfall in January was 4 6 of a foot below normal. But what was the overall change, right? And so that means you need to find the difference between the two here. So that means you're going to be subtracting two negative numbers, and you need to find the absolute value. This is what's the overall change. Okay, it's kind of applying the rules that we know for additive inverse, and that we know what overall change means. We look at numbers as being a value rather than being more positive or more negative. Okay, Kevin, you have a good day too. Okay. Oh, there's the bell. Thank you guys. Have a good rest of your day, and I will see you guys on Friday. It'll be our last math learning day on Friday. Bye, everyone.